If you've ever been involved in building, well, anything really, you know that awful feeling when a project just stalls?
Oh, yeah. That silence when a delivery truck doesn't show up.
Exactly.
Ah,
Or you get that phone call saying the price of steel just jumped overnight.
yeah.
Supply chain chaos in construction isn't just annoying, it's it's a huge killer of budgets. Leads to delays, costs spiral, and frankly just tons of stress.
It really is the biggest point of failure, especially in the build phase. You can have the perfect blueprint, but if the materials or the right crew aren't there when you need them, that plan kind of falls apart. And,
Mm,
historically, construction's been so vulnerable because forecasting was always looking backwards,
yeah.
always reactive.
Right. So our mission today is to really dig into the analysis around this revolutionary shift that's happening now. We're looking at how construction firms are using artificial intelligence, AI, to completely change the game,
Moving from reacting to problem.
to actually predicting them,
Yeah.
managing resources proactively.
Exactly. And if there's one thing, one immediate takeaway you should grasp right now, it's this. AI changes the underlying financial model.
How so?
Well, think about it. Traditional forecasting, it's based on like separate spreadsheets, maybe some historical data. Project managers have to build in these huge, expensive safety nets, these contingency budgets into every single bid.
Just in case.
Just in case. AI doesn't just guess better. It can turn, say, a critical material order from a 6-week high-risk gamble into something you can plan for 6 months out with real confidence.
Wow.
And that basically starts to eliminate a lot of that just-in-case spending.
Okay, so that's the core difference then. We're not just talking small improvements. It's a fundamental strategic shift away from relying on that expensive contingency.
Precisely.
So let's unpack that mechanism. What is it about AI that makes this possible? How does it move us from fixing problems after they happen to predicting risks before they even hit the project?
Well, it really comes down to handling complexity. Think about a human project manager, even a brilliant one. They're juggling so much already.
Right.
They might be able to manually track, 3, 4 critical things closely, materials, maybe key labor deadlines,
Yeah, the big stuff.
the big stuff. But construction has always been reactive because something unexpected happens, like a small strike at a port overseas, or a sudden political change affecting tariffs that impacts a delivery 3 months from now.
A human manager just wouldn't see that coming. It's invisible on their immediate radar.
Exactly. It's outside their immediate tracking scope. AI changes that.
So it's not just about predicting further out, it's about the sheer number of things it can watch at the same time.
That's it, precisely. The prediction mechanism works because AI algorithms analyze this incredible breadth of data all at once. Data no human team could possibly process simultaneously.
Like what kind of data are we talking about?
We're talking everything from hyperlocal weather forecasts along every single step of a transport route to really complex global shipping schedules, container availability, and crucially, the past performance of specific suppliers, maybe even down to the individual component level.
Okay, what I find fascinating here, based on the analysis, is that it's not static. It's not like you just run the numbers once.
No, absolutely not. That's the adaptive learning part. It's key.
Right.
These systems are built to constantly absorb new information. Every successful delivery, every unexpected delay, every price fluctuation for raw materials, it all feeds back in
So it refines the model.
constantly. It's not just software. It's like this ever-improving brain that's dedicated solely to that project's timeline and supply chain. It learns the subtle rhythms, the hidden risks specific to that type of job or that location.
Okay, so if the big picture goal is this learning, risk-spotting brain, what are the actual features? What does the project manager on the ground actually use that makes this so powerful?
Right, that brings us to the specific tools, the operational features. The first really critical one is what we call high-level data integration and analysis. And we're way beyond just looking at basic shipping updates here. This is where AI creates that holistic view you need. It pulls together data from incredibly diverse places.
Like?
Think about integrating the project's BIM model, the detailed digital blueprint, right, with live inventory feeds from your suppliers.
Right.
Add in historical bid data from past projects, maybe even real-time traffic data near the actual job site.
So you're literally connecting the digital plan of the building to the messy reality of getting the physical parts there.
Exactly. That level of detail takes prediction beyond just assumptions. It grounds it in hard, interconnected
The
data.
goal being much higher precision.
Much higher. Because now you're considering all the factors that could influence things, not just the couple of big ones a manager has time to worry about on a busy Friday.
Okay, that makes sense. And that leads right into the next key feature, which, reading the analysis, seems to be where the real money is saved. Predictive risk management.
Mm-hmm.
This is where the AI spots patterns. Patterns humans just miss because they involve too many moving parts.
That's the strategic edge, yes. For instance, the AI might predict a shortage of, say, specialized concrete additives. Why?
Okay, why?
Because it sees a combination of things. Maybe a known maintenance shutdown scheduled at a key chemical plant overseas,
Right.
combined with an unexpected surge in demand for that same additive because of, I don't know, a new regional building code that just passed.
Things a human wouldn't necessarily connect.
Very unlikely. And the AI flags that potential shortage weeks or even months in advance, giving the team time to react smartly, not scramble.
Okay, but hang on. If we're talking about analyzing global shipping, local policy, supplier data, doesn't that mean this is only for the giant multi-billion-dollar construction companies? Is the barrier to entry really high?
That's a really important question. And what the analysis shows is that while, yes, the early adopters were the huge firms,
Right.
the technology is actually democratizing pretty quickly. These tools are increasingly offered as like modular, cloud-based services.
Oh, okay. Software as a service.
Exactly. So you don't necessarily need a massive internal IT department anymore. What you need is reasonably clean data from your existing systems and, frankly, the willingness to integrate them.
And the cost.
Well, the argument now is that the cost of not adopting this kind of predictive tech, the cost of constantly dealing with those expensive surprises and delays, is often becoming higher than the investment needed to bring in the AI.
That really shifts the perspective on cost. Which brings us to the third feature you mentioned, cost optimization itself. So if you can predict these potential train wrecks ahead of time,
You're not just reacting anymore. You're making proactive, cost-effective decisions before the crisis hits.
like finding a different supplier,
Or maybe finding an alternative shipping route, even if it's slightly slower but avoids a predicted port bottleneck. Or changing the delivery method entirely.
weeks in advance.
Weeks, sometimes months. And minimizing those delays, that's the ultimate key to cost efficiency, right? You keep the project on budget by essentially nipping expensive problems in the bud.
It really moves resource management away from educated guesswork.
And firmly into the realm of data science. It becomes a strategic advantage.
Okay, let's make this even more concrete. Let's talk about where this AI actually hits the job site. Where are we seeing the most immediate sort of tangible impacts?
Predictably, the first major area is material procurement. That's often the biggest headache.
Makes sense.
So the AI isn't just looking at a supplier's promised delivery date. That's basic. It's doing hyper-granular risk scoring for every single vendor.
Based on what?
Based on deep historical performance data, maybe recent delivery times on similar routes, comparing that against current real-time shipping lane congestion data, things like that.
So the project manager isn't just crossing their fingers hoping the concrete truck shows up next Tuesday.
No. They might see, say, an 80% risk flag pop up for supplier X's delivery next week because of a predicted weather system hitting their distribution hub.
And the action is?
The action is proactive. They immediately look at shifting part of that order to supplier Y, who has a lower risk profile for that specific time frame.
They solve the problem before it is a problem.
That's the whole point. The sources actually detail this case study of a hospital project. They saved something like 3 weeks on a critical phase.
Oh.
The AI predicted that a specific crucial structural steel component was going to get stuck in a particular regional port. Why? Because of a seasonal labor slowdown there that wasn't even widely publicized yet.
Wow.
That early warning allowed them to pivot to a different supplier and fabrication shop, completely bypassing what would have been a month-long stall on site.
That's a massive impact. Okay, what's the second big application area?
Just as critical, labor management.
Yes, having the right people with the right skills at the right time.
Exactly. Delays aren't just about materials. They're often about not having the specialized crew you need when a specific task comes up on the schedule.
So how does AI help there?
Well, these tools can now forecast potential labor shortages. They do this by mapping the required skill sets from the project plan against real-time local labor availability data, factoring in demand from other nearby projects too.
So it sees competition for workers.
It can. If the system knows you need, say, 5 certified high-rise welders in 3 weeks, and it sees a big competing project nearby just posted openings for 10.
It flags a potential gap.
It flags a potential gap, yeah. Giving the manager time to secure those resources, maybe adjust the schedule slightly or confirm commitments. It's about ensuring the right people are there when needed, avoiding those costly idle times.
Okay, materials, labor. What about the things we really can't control, like the weather?
Right, Mother Nature. That's the third key application area, managing environmental factors.
So better weather forecasting.
It's more than just a standard forecast. AI systems integrate both long-range and hyper-local weather predictions, often not just for the job site itself, but for key points along the supply routes as well.
So it anticipates disruptions beyond just rain on site.
Exactly. It could be a hurricane threatening a port where your materials are due to arrive, or an extreme heat wave predicted for the week you're planning a major concrete pour, which affects curing times, or even intense cold impacting sensitive installations.
And the benefit is the early warning.
Yes, managers get these predictive alerts that allows them to maybe shift schedules around, perhaps bring some interior work forward if heavy rain is forecast, or plan ahead for temporary heating or cooling solutions to keep specialized tasks on track.
Instead of just reacting with a down tools day when the bad weather hits.
Precisely. It avoids forced downtime. So you see, these specific applications, materials, labor, environment, they really demonstrate how AI is becoming, well, kind of indispensable.
It moves the whole team from just managing the chaos of the day.
To actively optimizing the workflow for the weeks and months ahead, reduced costs, better efficiency.
Okay, so to sort of pull this all together, to synthesize what we've covered, the clear takeaway from the analysis seems to be that these AI-powered forecasting tools, they're rapidly moving from nice-to-have to must-have infrastructure in construction.
Absolutely. They provide that critical foresight needed for timely completion, for smart resource use, and for keeping finances under control.
The future of construction really is becoming smart construction.
And this isn't slowing down anything, it's accelerating. We're basically watching the birth of the truly intelligent construction site, where those big, unexpected supply chain delays, they'll soon be seen as, historical artifacts rather than just the cost of doing business.
Which leads us to a really interesting final thought for you, the listener, to chew on. Given that the core strength here is that these AI systems learn and adapt, getting better and more accurate with every bit of new data, we have to ask, what new patterns, what subtle risks that are completely invisible to human managers today? The current unknown unknowns, right? What will AI reveal as just standard, predictable operational risks in supply chains, say, 10 years from now?
That's the fascinating question. We spent decades fighting the obvious fires. What hidden complexities is the machine learning about to make common knowledge? That's the real long-term power here.